Here we have the electron beam deflection tube again, but in a slightly different configuration. So I've removed the Helmholtz coils from around the evacuated bulb, so we're not looking at using a magnetic field to deflect the electrons this time. What I've got now is another high voltage power supply that's connected via these connectors to this metal plate, and we're going to apply a high voltage across this plate to create an electric field, and see what happens when we use that to deflect the beam of electrons. So I've had the filament warming up, so if we increase the anode voltage to the electron gum, you can see we get, as the voltage increases, we get a more intense beam of electrons. Okay, so there we're at 4000 volts. Hopefully you can see that nice blue trace there on the graduated scale, and you can see at the moment that it's completely horizontal. There's nothing, no forces acting on the electron beam at the moment. If I turn on the other voltage supply, so this is acting across here, so we're going to apply an electric field. You can see we're already starting to get a slight deflection, and if I increase the voltage here, you can see there's a arc, a parabola beginning to become visible. So the electron beam is being influenced by the electric field across the bulb, and the electrons are being deflected upwards. Let's see if I can take some measurements. So that is almost exactly 3000 volts generating the electric field across that plate, and if I take the readings off the scale for 8 centimeters of horizontal movement, we've got 2 centimeters of vertical deflection. And if I take the voltage back down, let's collect another data point. Okay, so that's a bit less now, so we've got almost exactly 1 centimeter of vertical deflection for the same 8 centimeters of horizontal movement, and that is at a voltage of 1600 volts.